Hello everyone, my name is Jaime Flores and today we'll be talking about a genetic disorder, and mine is tyrosinemia type 1. And we'll be going over several things, some history on it, prevalence, the probability of getting this disease, physical effects, and among other things. So first we have history. So tyrosinemia type 1 is a type of genetic disorder, specifically a metabolic disorder that is caused by a disruption in the breakdown process of the amino acid tyrosine. This disease causes excessive buildup of tyrosine and its byproducts in tissue and organs. And there are three types of this tyrosinemia, with type 1, which is the one we're going to go over, being the most severe. The prevalence, tyrosinemia type 1 affects approximately 1 out of 100,000 people across the world. And it varies by region, of course, and in places such as Quebec, Canada, 1 out of 1846 people are affected. So obviously in that region there's more people that are prone to getting this disease or disorder. So physical effects, what symptoms do you experience with this? So again, tyrosinemia type 1 is the most severe one, and this disorder presents itself with symptoms in the body rapidly within the first few months. So a newborn will display such symptoms. Infants with the disorder have difficulty gaining weight as well as a stalled growth rate due to the inability to digest high protein foods, which leads to diarrhea and vomiting. They may also be jaundiced and are susceptible to bleeding, especially nosebleeds. So the molecular cause of the disorder, what exactly causes this? So it's actually a mutation in the FAH gene, and we'll be going over that here in a second of what exactly is the FAH gene. And the mutation is in the chromosome 15. Chromosome 15, Q25.1 region. And this provides instruction for AH enzyme, which is used in the last step for the breakdown of tyrosine. So FAH, so let's see if I can pronounce this correctly. Fumarole acetoacetate hydrolysis gene. So this gene, this is also known as the FAH gene, and its amino acid length is 419. Its function, like I said earlier, the region where the mutation usually occurs is responsible for providing instructions for the FAH enzyme, which is used in the last step for the breakdown of tyrosine. So that's the reason if there's a mutation in this gene, there's an inability to further break down this tyrosine, so there's a buildup of this amino acid in the system. And the mode of inheritance. So this disorder is a condition inherited in an autosomal recessive pattern. It means that the mutation of the gene are present at both of the copies of the gene. And for this pedigree example, we have I do realize it's cystic fibrosis, but the mode of inheritance is the same, which is recessive autosomal. So we can go from there. So here we can look at both Jim and Alice, which are at the top, 70 and 69, their ages respectively. They're both carriers since it's a recessive, and they contain a dominant and a recessive allele. So, in theory, only one of them should have gotten the disease, the disorder, but two of them actually got it. But which was Jack, which is 50, and Leah, she's 43, and they both got the disease. So from there, and we can see that Paul, he's not a carrier, or he does not carry the disease. Jess, on the other hand, she's a carrier, and it just goes from there. Again, Jack, he has the disorder. Lena is not a carrier or carries the disease, or has the disease. So therefore, out of their offspring, they're gonna be carriers, and it goes from there. With Leah, since John is a carrier, Leah has the disorder. Therefore, there's, per a Punnett square, there's a 50% chance that they either have it or don't have it. And that's a little bit of background on this pedigree example. Now we can go to genetic testing. So for this, there are several options, several tests that you can go through. Approximately 123 tests. The one that would be more beneficial would be one that is called newborn testing, provided by Central ICU, which focuses on the sequence analysis of the entire coding region. This one has the ability to know 767 conditions. And this kind of testing is not mandatory, but highly recommended if some symptoms are displayed for this disorder. And for this disease, since there's an immediate display of symptoms, it is crucial that there's an early detection for this, as it can lead to several complications for that individual. The company that offers this is again Central ICU, and they have their lab in Germany, which is most of these tests is where they're sent to. And as far as genetic testing controversy, this kind of testing does not have any known controversies. It's pretty straightforward. I mean, if they display symptoms, they go through with it and they test you for it. And as far as treatment, there's actually no cure for this. For tyrosinemia type 1, the individuals affected for this disorder, they can be on a special or strict diet, which is only restricted to a few amino acids. And also, there's a medication that these individuals can be treated with, and it's nitazoxanide. And that's all I got. Here's my reference table. And thanks for watching. Any input would be helpful, and thanks again.